This conference will now be recorded.
Now let us find the convolution of a rectangular function with the same rectangular function, that is x1 of t, that is taken as rectangular of t by 4, and let us consider x2 of t, same rectangular function t by 4. So let us find y of t equal to x1 of t convolution x2 of t. So that y of t, we know that the expansion of convolution integral, it is x1 of tau x2 of t minus tau d tau. So first get x1 of, that is on tau axis, the rectangle function with amplitude 1. Now to plot x2 of t minus tau on tau axis, it is a reflected shifted signal. So the shifted, this x2 of tau is equal to x1 of tau. So here the shifting constant t can be from minus infinity to plus infinity. We can consider different possible cases for this t. So in the first case, let us consider this t is this x2 of tau. It is the right edge. If it is t, the left edge, it should be t minus 4, because of the width of the pulse, it should be 4. Now in the first case, we can consider t value less than minus 2. And in the second case, let us consider t value, that is minus 2 less than t less than 2. And in the third case, let us consider t value greater than 2. So let us find the convolution integral in these three cases. So in the first case, when t value less than minus 2, we have x1 of tau, it is the rectangle function from minus 2 to plus 2, and x2 of t minus tau, here the pulse with the second edge t, which is less than minus 2. So let us consider minus 2 somewhere here. So the product of these two signals, x1 of tau, x2 of t minus tau, is 0 throughout, is 0 for the case when t considered as less than minus 2. Let us consider the second case. It is minus 2 less than t less than plus 2. In this case, if we consider x1 of tau, that is from minus 2 to plus 2, and x2 of t minus tau, so t should be starting in the range minus 2 to plus 2. So that let us consider t here, and minus 2 plus 2, so that this will be t minus 4. So the product of these two in the second case, if we consider, this will be non-zero over the 2 to t. So both signals having non-zero part x1 of tau and x2 of t minus tau will be non-zero in the limit from minus 2 less than tau less than integral. Within this limit y of t it is. So the tau range is now minus 2 to plus t. So minus 2 to plus t, the both functions having amplitude 1, so that x1 of tau, x2 of t minus tau, d tau, which is equal to d tau, that is tau with the tau ranging from minus 2 to t. Y of t is, after substitution of the limits, t plus 2 whenever minus 2 less than t less than 2. Now let us consider the third case. It is t value greater than plus 2. In this case, consider x1 not tau and x2 of tau. We are considering that t value greater than 2. So we can consider the plot like this: t minus 4. So 2 should be somewhere of t minus tau. When we consider that t value is greater than 2, so that let us take t minus 4 on this signal at this instant. So y of t, which is equal to minus into plus infinity x1 of tau x2 of t minus tau d tau. So this product is non-zero to 2. In both signals we have amplitude equal to 1. So that this will be 1. So the given limits t minus 4 to upper limit 2. And this will be 1 d tau. That is tau with the tau ranging from t minus 4 to 2. That is equal to, after substitution of the limits, it is 2 minus r t minus 4. It is equal to 6 minus t whenever t is greater than 2. Now we can consider that t minus 4, whenever we are considering t greater than 2, the t minus 4 value should be less than 2. So in that case, if t minus 4 is less than 2, t value should be less than 6. So this condition, so the third case, it is y of t can be written as 6 minus t over the limit 2 less than t less than 6. So fourth case, that equals to t minus 4 value will be greater than 2. In such case, we will get t minus 4 greater than 2, so that there will be no non-zero part for x1 of tau and x2 of t minus tau. Therefore, we can consider that y of t is 0 for this range. So finally, we got the four cases. It is in the first case, y of t is 0 for the range, and in the second case, we got that is t plus 2 whenever minus 2 less than t less than 2, and it is 6 minus t from 2 to 6, and 6 onwards it is again 0. So let us write these four conditions and let us plot the signal y of t. So y of t, it is equal to 0 when t value less than is equal to t plus 2 whenever minus 2 less than t less than 2, and it is equal to 6 minus t whenever 2 less than t less than 6 is equal to 0 if t greater than 6. So if you plot the signal y of t, so 6, so minus 2 to plus 2, the signal is t plus 2. So we have a shifted ramp function like this. And the 6 minus t plot, it will be reflected and shifted ramp function, so that we'll get at 3, 6 minus 3, it is 3. At 2, we have the function y of t is equal to that at 3 it is 3, and at 4 if we consider it is 6 minus 4, it is 2, and at 5 if we consider it is 6 minus, so that it is a falling ramp function. Similarly, we can observe at minus 1 it is 2 minus 1, it is plus 1. At 0, t plus 0, 2 plus 0 it is 2, and it is plus 1, it is 2 plus 1, 3. rectangular function from the y of t as shown in this figure. So we can conclude that a rectangular function from -2 to +2 is convolution with the same rectangular function, then that should be equal to a triangular function so that we can observe that here the width of the pulse tau 1 if it is equal to 4. Here the width of the pulse tau 2 if it is equal to 4. Here total width of the triangular function it should be equal to tau 1 plus tau 2. Of course in this case tau 1 equal to tau 2 so that it is width of the rectangular pulse.